Hello everyone, and this video is about the first part of the periodic table. So in this video, we would mainly focus on the brief history of the development of the periodic table, and then to introduce to what is periodic table and what do you find about the modern periodic table and why we say that periodic. So this periodic table was drafted by a very famous Russian scientist. We call that Mendeleev. With the German Mendeleev, so he just make he arranged those 63 elements known at the time in the table form. So how do they place it? Well, first of all, they put the elements with the similar chemical properties, okay, in the same vertical column of the table, and also those 63 elements they are ranked in order of increasing atomic mass. At the time, people at the time have already known how to count the relative atomic mass, okay, uh, of those elements. So we have got those two things. First of all, it is about according to the increasing RAM, and then trying to rank it in according to the similar chemical properties. Okay, similar chemical properties in the same vertical column. So at that time, the German Mendeleev, they have made something like this. Okay, so you may see that those today, to his belief, he would think he would try to rank those, right? You may see that 1, 11, 12, and actually what you will find it in a modern periodic table is just a what? It is the RAM, right? Very similar to the RAM, relative atomic mass, and I try to rank it from smallest, from the lightest to the heaviest. And later on, we would like to take a look on horizontally. So they would find that, okay, so for example, oxygen and sulfur and selenium, they are and also this one, okay, and they are ranked they're grouped together simply because they have similar chemical properties, okay, and so as right, carbon, silicon. So can you see that? Okay, and it is what you know in about non-metals and semi-metals. How about metals? Metals, well, he can even think of this one, and this is what we know in group 1 nowadays, but at the time he has successfully make those ranking, which is very similar to modern periodic table. Can you see that? It is group 1, right? Can you see that? This is group 1 metals. It is group 6, and this is group 4, and group 5 is here, right? So you may see that, right? In group 7 here, and finally you may find group 2 here, right? Beryllium, magnesium, and then later on, okay, these two, they are in group 2 and group 3, right? Very similar. And at that time, what we see that no more gas, right? No more noble gas, because it's too stable. So it is quite difficult to process to show its own properties such that the people would find it easily. Okay, so they will not find it so easily. So this is the Tetramer Mendeleev, they rank it in the past. How now nowadays? So nowadays, we will have that modern periodic table. So you may find that, wow, this time we are now ranking according to the increasing atomic number, but not, okay, but not RAM, okay, but not relative atomic mass. The simple reason behind is very simple. For example, if you take a look on argon, right? Argon is 39.5, but for potassium is 39.1, right? Which is for RAM of potassium, it is slightly lower than argon, right? You see that. So the ranking will be a little bit different. So why will we have a change from the ranking from increasing RAM to increasing atomic number, and it is something about what? is something about number of electrons. Okay, so I would like to explain to you later. Okay, why would those elements they rank according to atomic number, and especially it is related to the number of electrons. Okay, so what you will find it is on okay, you see the hydrogen come first and the helium comes second. So you may find hydrogen is just odd one out, right? It is quite different from different groups. Okay, so for hydrogen, it is a very special case. Okay, in which it doesn't belong to any group. Okay, does not belong to any groups. So you may find that okay, so you will just kick out from the from most of the elements, and they try to isolate it. They be isolated here. So this is what we'd like to have a quantum periodic table, and you may find those two terms, right? You may see that groups and periods. Groups and periods. What are they? Groups and periods. Okay. Groups we call it 周groups we call it 组 periods we call it 周期 groups 组 and this one 周期 so what are they? So well if you want to talk about groups, it is related to number of outermost shell electrons. Okay, so if I count the lithium as an example, you may know that lithium is group 1 simply because they have the last digit, right, to 1, right? The electronic arrangement of this one is 1. So the number of outermost shell electrons is just 1. So we rank number 1, group 1. So how about sodium? 2H1, we have got the electronic arrangement 2H1. Again, those 1 electrons, it is found in the outermost shells. So we will call it classified as group 1. So similarly for this one, fluorine, we have got 2,7 as the electronic arrangement. You may see that in group 7. How about this one? Group 0 is very strange. It's because for helium, it is is in group 0, but the outermost shell electrons is just 2. Okay, but for neon, it is 2H8. But for argon, 2H, sorry, and for argon is 2H8. So you may find that the last digit, okay, the last digit here, it is 8. Is either 2 or 8, right? So you may find that in group 0. How about when you try to take a look horizontally, okay, horizontally, it will call it in period. So if we thought is the first period, which means they have if it refers to the number of occupied electron shells. So what is mean by that? Number of occupied electron shells. For example, for lithium, as once again, okay, lithium is put in period 2 simply because you have got its electron diagram like this. Okay, we have got 2 occupied electron shells. Okay, you count it 1 and 2, right? You see that 2. So we have got the period 2. So remember the notation is different. If you write down the periods, all those they are just Arabic number, 阿拉伯数字. While for groups, they are in capital Roman. So you may see that 1, 2, 3, 4, and except the 0, you may find that 5, 6, and 7. All those they are in capital Roman. While for the period, they are in what? They are in Arabic. Okay, so this is what you may know about the modern periodic table. What else? What else you know about periodic table? So you may find that most of them they are metals. So they will find it on the left hand side, right? While for the right hand side, you may see that we have got a number of non-metals. While the semi-metal, you find it in green. So it's a zigzag pathway. You see that it is a very few. It joins the minority of the periodic table. What else? So you may find that the gases, most of them you may get the gases as non-metals at room temperature pressure, while for the semi-metal they are mainly solid. Okay, and for metal they are most of them solid except mercury is a liquid metal. And you may find a liquid non-metal, which is bromine. Okay, non-metal, which is a liquid, which is bromine. So this is what you may know about the periodic table. So we just start from, shall we have a recap of this now? And you may refer to the electronic arrangement of some elements they are grouped into your notes. So you may find that it agrees with what we have just said last time, right? We talk about the periodic table like this, okay? So what are they? So you may find that for the lithium, sodium, and potassium, I would say that in group 1, simply because the outermost shell we have got 1 electrons, so it is group 1. How about fluorine and chlorine? It is group 7, because the outermost shell electrons contain 7 electrons. Okay, so you may find that the biggest circle here, it is the electron shell. We have just count the number of crosses, which represents the number of electrons in the outermost shell. If I want to take a look on the horizontally, you may see that what are the in common for those elements is that they will have, for example, the first row is of one circle, 2 circles, 3 circles, or four circles. What are they? We call the number of occupied electron shells. We call it period. Okay, so this agrees with what you have learned in the last chapter. Now, so remember the period number, it is in Arabic, right? While the group number, it is in Roman, capital Roman. So this is what you may find it, right? Written in Arabic and written in Roman. Can you see that? So this is what I'd like to remind all of you. 周期我族 in periodic table. Now, maybe some of you may have doubts. Well, how come it is set as periodic table, and how come they would have a ending about the helium, neon, and argon? They would jump to another row, but why not I have another way of making the periodic table, but like this? So it is more or less something about the term periodic. Okay, so before we say anything about the periodic pattern, I would like to show you some more information about the in between group 2 and group 3. Can you see that group 2 and group 3 we have got transition metals or transition elements, 過渡性元素 or 過渡性金屬. So we will see the common metals are just like iron and copper, they are transition metals. So where we will find the transition metals, it is in between group 2 here and group 3. So you may find the expansion of the spaces here, right? You've got 10 elements here from scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, all those they are found here. So if you want to take a look on vertically, you may see the 3 commonly found metals here: copper and silver and gold. Can you see that? Mercury and platinum. So you may find those metals, they are there. So this is what you may know about the periodic table. So we have got some exception, right? I've just mentioned, first of all, hydrogen does not belong to any group. Okay, could you please underline that term? Hydrogen does not belong to any group with the periodic table, because although we have got one outermost shell electron, so according to the classification, it should be group 1, right? However, hydrogen is just a gas, while for group 1 elements, they are just solid. Okay, so there's properties, they are not similar as you may find it in group 1 elements. Okay, and second, you may find that for group 1 elements, they are just metals, while for hydrogen, it is non-metal. So for hydrogen, even though they have this first outermost, you have got one outermost shell electrons, it is generally not be classified into group 1. Second is about group 0. What's so strange about group 0? Group 0, the atoms of the first member have the 2 outermost shell electrons. What is now referring to is helium. Okay, We are now referring to helium. And for those other members, just like neon, argon, etc. So what are they? They have the 8 outermost shell electrons. Okay, so we cannot name it as group 8 because the number of outermost shell electrons is quite inconsistent among those different elements. So to such that they would name it as 0 instead. Now this is what you may know about the brief introduction of the periodic table. Now for 6.3 we will talk something more about the periodic pattern. Right? How would you say that we have got the periodic pattern? So you may see we are now ranking period 2 and period 3 elements according to the physical state, melting point, boiling point, okay, electrical conductivity, the types of elements it is related, and atomic radius, how large it is. So which is measured from the nucleus to the outermost shell, which is the distance between the nucleus and the outermost shell electrons. Okay, so this is what we call it as atomic radius. So finally, its reactivity is something what we call it as a chemical property. So what are they? So you may find those. So I would like to give you some seconds to take a look on that. Do you find some patterns? Do you find some special pattern? Yes, that's right. So for some people, you may find it quite difficult to visualize it. So the best way to understand this is to show you some graphs. Now, first of all, you talk about melting point and boiling point. As said before, on the left hand side is solid, and on the right hand side is gas, or maybe some of them they are liquid. A part of them, a few of them, they are solid. So I would like to show this melting point and boiling point in terms of a graph. So you may see something like this. Okay, first of all, boiling point. So what will you see? What will you have it? Now, well, you may have the group number from group 1 to group 0 on the x-axis, while one for the y-axis is boiling point in degrees Celsius. So the room temperature is somewhere here, right? It's somewhere here. So room temperature is somewhere here. So what will you get? Well, first of all, if you want to talk about, it will show the periodic pattern, simply because you may find it, the boiling point, it just climbs from group 1 to group 4. Can you see that? It climbs from group 1 to group 4, and they will drop. It will drop from group 5 to group 0. And that pattern that will occur periodically. Of course, the exact boiling point may not be the same when you go down the period and try to analyze, but you may see will have, it seems like the shape of a hill, right? From group 1 to group 4 climbs, increases, while for group 5 to group 0 decreases. So this is what you know about the boiling point. Now, if you want to take a look on the melting point, they will show you also a similar trend. As said before, group 1 to group 4 an increasing trend, and while for group 5 to group 0 a downward trend. So you may see those what we call it as a periodic trend. Okay, so this is the first one. So if you take a look on the statement number 1 across the period, so what will you get is this one. The melting point or boiling point rises to elements in group 4, and then falls to low value. So you may see that the trend, it seems like hill. Before we come up with the electrical conductivity, let's try to take a look on this, right? So what do you find about periodic pattern? Yes, it is the atomic radius. Okay, periodic pattern for atomic radius. So what you see across the period? How you know we are counting across the period? So you may find this one. This is period 1. and then here comes period 2, period 3, okay, period 4. Can you see that? So up to 10 is neon. So you may find that what happens to the atomic radius, it decreases. Okay, so if you want to take a look on the electrical conductivity, you may guess, so it may more there will be decreases, right, from metals to semi-metals or non-metals. Those you may find it. So apart from the group 0, what's next is about the reactivity. Okay, reactivity. Apart from 0 elements, we call it noble gas. The most reactive metals, they are near the what? Near the edges, which means group 1 and group 7. Okay, and the least reactive ones, they are in the middle, which means group 4, mainly group 4. So you may find that across the periodic pattern, and this is what I would like to ask you guys to memorize it well. Okay, so you may find some other periodic pattern in the periodic table. You may find, so this is what I would like to talk to you about the periodic pattern. Okay, so you may find quite a lot. So for example, this diagram in our Form 3 syllabus, what you may know mainly is on these arrow, right? Atomic radius across the period decreases, metallic character decreases. So you may find that for these two items we should be highly noted. Okay, so this is what we will talk a bit about the patterns in periodic table. So very interesting finding, right? For the others, just like you see the other terms, you will know it in Form 4 above in chemistry. Now, shall we take a look on the checkpoint? So you may have oxygen, sodium, calcium, and helium with that atomic number, electronic arrangement, period, group. Can you find it one by one? So atomic number is 8, electronic arrangement is 2, 6. Okay, so you may find that we have got two numbers here. So period is 2, group refer to what? Refer to the last number. Okay, the last number. Group, we are going to talk about this. Okay, so you may find that it is 6. Okay, so what's next is on sodium. Sodium is 11 with the electronic arrangement to which 1. So what does the period means? Period means you count the number of occupied electron shell. So it is 2 for oxygen, 1 for sodium. It is now becoming 3. Okay, and similarly, if you want to talk about group, we are going to take a look on this number. It is group 1. So in order to write down those group, remember to what? Remember to put a Roman capital letter, okay, capital Roman number. So you may find that for this one, I just write wrongly. It is group 6. It is in Roman capital, and this one group 1 in Roman capital. How about calcium? Calcium will have got atomic number of 20 with the electronic arrangement 2, 8, 8, 2. So it is period what? Period. So what you're going to count is on the number of occupied electron shell, 4 numbers, which means period 4. Okay. While for the group, you are going to take a look on the last number. It's got 2 electrons in the atomic shell. So for the group, it is group 2 in capital Roman. How about the last one, helium? Helium with atomic number 2, so electronic arrangement is just 2. Period 1. Okay, so because you have just one occupied electron shell, while for the group, you need to take a look on the final number. If you write down this 2, it is not correct. Okay, it is group 0. So very, very special case. Okay, it's very, very special case. Why is it not group 2 but group 0? Because it is the first shell, the accommodation, right? The maximum number of outermost shell electrons, it is 2. Okay, so this is the last element in period 1, so it is group 0. So remember, a very special case for this. Okay, so we try to take a look on question 2. An atom of an element X as the following structure. So to which period and group of the periodic table does element X belong? So you may find, you may count, but count what? Or you need not count the number of the crosses for the time being. If you count it, you know it, it is 35. So what is that? We've got 1, 2, 3, 4, 4 circles. What does it mean by that? 4 circles mean period 4. Why? Because we have got 4 occupied electron shells. Okay, so we have got a period 4. How about group? If you want to take a look at the group, you are going to find out the last, the outermost shell. 1, 2, 3, 4, 5, 6, 7. So you may find that it is group 7. We will call it as halogens, okay? 7 outermost shell electrons. So we will call that group 7. So what is the atomic number? Is 35, as I said before. Complete periodic table, name element X. What is that? You find it in the periodic table. What is that? Well, period 4, group 7. So what is that? Yes, that's right. It is bromine. Okay, it's bromine. So you may find it, you may write it down for this one, bromine. BROMINE. Name and other elements in which you would expect to have a similar chemical property. As said before, similar chemical properties, they are found in the same group. So in same group. So you may find it on group 7, just count. What are the remaining? Okay, yes, that's right. You may try it out fluorine and chlorine. And this agrees with what the German leaf have made in the past, right? We will talk about this. Okay, you may find that for fluorine, chlorine, bromine, iodine. So you see that they try to group that onto the same group simply because they have similar chemical property. Okay, so you may write down any other elements in group 7. Fluorine, chlorine, iodine. You can, okay? So this is what you know in question 2. How about question 3? The diagram below shows part of the periodic table. Using the letters given A to J, find out the elements which is extremely inert. Okay, so what's mean by extremely inert? Is chemically stable. So what is that? Okay, yes, that's right. This is F. Okay, what is that actually? It's neon, noble gas, and is located in period 3, group 7. Period 3, group 7. So what is that? It's I. Okay, so I is chlorine actually. So we know that as chlorine is neon. As 4 outermost shell electrons in an atom. 4. 1, 2, 3, 4. 4, you may count it 4. Is J. What is that? It is potassium. Okay, indeed we've got 2 or it's not J. Oh, so I confused, right? This one. Remember not to get confused, right? This one, it is 2H1 for C. How about D? How about C? It is quite the opposite, right? It's not the one. 4 outermost shell electrons in an atom. So remember that 2 term is quite different. 4 outermost shell electrons, which means what? You are going to find the group 1, 2, 3, and 4. It is H. What is that? It's a silicon. Okay, group 4. So mark it as 2H4. So it will be easily confused actually. Outermost shell electrons we've got 4. You are now referring to this. Okay? How about the other one? And for occupied electron shell, you are going to count 1, 2, 3, 4. 4 circles for K. K, we've got 1, 2, 3, and finally, this is the one, right? So you may find the 4 occupied electron shell, 4 circles have been written. How about E? How about E? E has similar chemical properties as calcium. So calcium belongs to group 2. Group 2. So you are going to find out which one belongs to group 2, and that is the one we show the similar chemical property. This is J. That is G. Sorry, it's G, which is that one is this is magnesium. And finally, is the most reactive metals. Which one is the most reactive metals? So you may find that the most reactive part should be on the left-hand side, okay? Left-hand side, most reactive. While for B and J, what is more reactive? And that is J, okay? J. So what is that? It is potassium. Okay, so why is it like that? I would like to give you the reasons in another video. So in short, you may see that something very highly confusing. So I would like to address to all of you. First of all, outermost shell electrons. Second, occupied electron shell. They are now talking about different things. So if you want to talk about outermost shell electrons, which means the shells which is occupied but the furthest apart from the nucleus. So you may find for this one as an example for outermost shell electrons, which means the furthest occupied electron shell, we have got 4 electrons. So in this case, it's silicon 2H4. So you are going, if you know something about the electron arrangement, what you need to do is to check the last number. The last number. Now, second is the occupied electron shell. What does it mean by occupied electron shell? It is you are going to find the number of circles. You're going to draw the number of circles in the electron diagram. So and then put a cross here. For those crosses which has been put in the circle, which means those electrons has been occupied. Okay, so we've got 4 electron shells. So you are going to count it from the first shell to the 4th shell. For potassium, it has 4 occupied electron shells. So that's why you write down as 2,8,8,1. So you are going to find the 4 numbers, and you know that 4 occupied electron shells. So what are they? If you want to specify the outermost electrons number, what is that? We call it group. We call it group. While for the other one, what we call that? Period. So this is what I would like to share with you on this video. So remember that 2 terms. And for period, Arabic numbers. How about group? Roman. Okay, so I do hope this is the first video about chapter 6, and I do hope all of you could get what I mean. And I would like to show you another 2 videos to take a look on the diagonal groups. Okay, you take a look on the vertically to see the common properties while those groups have. So see you in the next video. Bye bye.